Let's take a look at these two graphing questions from Larson's calculus. So the first one is r equals to cosine theta. All we have to do is graph this. It's given in cylindrical coordinates right now. And because it's given in cylindrical coordinates, we know that the z value, which is not mentioned here, it can be anything. So it would look something like this, right? Z can range over all real values. So it might be a cylinder that looks something like this. Okay, so that's something to keep in mind for the first question. For the second question, there's no such limitation. We have z, we've got r, which is going to break down into y and x. So let's start with the first question. One thing that we can do is notice that if we just had an r over here, the r cosine theta would give us an x. Luckily for us, we can bring an r there by multiplying both sides by r. By doing this, you can do that, right? By doing the same thing to both sides of the equation. Left hand side now becomes r squared. This becomes 2r cosine theta. Left hand side, r squared is just x squared plus y squared. And the right hand side now is 2x. So we now we just complete the square, right? It's like any circle that you make, same exact process. So x squared minus 2x plus 1 plus y squared equals 1. Here we added 1 to both sides to complete the square. This gives us a very nice, neat little circle, x minus 1 whole squared plus y squared equals 1. If we were to graph that, we could do something like this. So this would be our z-axis, that would be our x-axis, and our y-axis. We're centered at 1. It's got a radius of 1, so it'll look something like this. Sorry, something like this. And now, since it's a cylinder, we just go up. Okay, it's not looking very neat here, so I want to do a different color so you can see the top, hopefully. Something like this. Right, so it just looks like that. It's basically just a cylinder, and it goes up forever in the z direction, down forever in the z direction. So it's like infinite circles stacked up over one another. That's one way of thinking about it. Let's move on to the second one. And I've actually never tried this second question before. This is going to be my first time, so hopefully I don't mess it up. We know that the left hand side is just z, right? So I'll write it the usual way. I write z. The right hand side is r squared cosine of 2 theta. We can't really do anything with that unless we simplify it. And I think this is the formula, I believe. Worst case, I'm wrong, but I think this should be fine. So we have z is equal to r squared times 1 plus cosine squared theta over 2. So let's break this up a little. We get 1 half r squared plus 1 half r squared cosine squared theta. Perfect. What is 1 half r squared? What is r squared? That's just x squared plus y squared. And then this over here is 1 half times r cosine theta whole square. So let's rewrite this now. Plus 1 half, and then this is just x squared. Right? Yep. So now we have z is equal to 1 half x squared plus 1 half x squared. That's just going to give us x squared, and then we have plus 1 half y squared. And what this would look like is, let's actually graph it. Right? There is a way to go about doing this in a more, standardized way. But we can just kind of plug in a few points and see what this will look like, and then hopefully go from there. So I think there should be a paraboloid, an elliptical paraboloid on the z-axis, right? If you think about it. So let me choose a slightly different color. It's not going to be perfect what I draw. If you want, you can like draw this on Desmos 3D or something and check what it looks like over there. But we can start by just drawing the traces, right? So we can just say when when x and y are both 0, so this is the x-axis, this is the y-axis. When x and y are both 0, we're just going to have 0, 0, 0. When z is 1, we're going to end up having an ellipse, right? That's why it's an elliptical paraboloid, as I was guessing earlier, and I think I'm pretty confident in that now. Y is going to be, it's going to be scaled in the y direction, so it's going to be something like this. This is the ellipse that we have. And the way that it's going to look is that it's going to come out at you like this, right? It's going to like protrude out in that way, I guess. And then So these are the different traces that you have. And I know it's very difficult to kind of see it like this, but okay, so let me do it one at a time, right? This is going to be your yz trace, right? If x is equal to 0, it's just z equals 1 half y squared, which is a parabola. If y is equal to 0, it's x equals z squared, which is another parabola. It should look something like this. It'll be a little steeper. It'll be twice as steep. And then um, there is no, like the xy trace would just be a point because z is equal to 0, so x squared plus y squared is 0, which is only at 0 comma 0. But in general, so I'm not going to draw that ellipse, but if z is 1, it would be that ellipse and so on, right? So what it would look like, what I'm trying to say is that it would look something like this. Okay, so it's, and then it would look a little bit better than that, obviously. And what you see here is basically an ellipse. It's kind of like a funnel, I guess. Right, I'm going to trace it out a little bit so you can see it better. It looks very messy right now. I might open it up on Desmos 3Ds just so you can get a better sense of what it looks like. I'll do this in violet. But yeah, so this is like the general shape, right? It goes through the origin over here, comes out on this side, and it's kind of flat here. In the other direction, the XZ direction, it still goes down there. It's considerably steeper over here, right? And at any point, any Z value that you take, you're going to have an ellipse over here. Okay, so hopefully that makes it a little bit easier on the eyes. I know it looks pretty messy, but that's basically what it looks like. Hopefully you can kind of visualize that. Worst case, I think just open this up on Desmos 3D and they'll give you a better drawing. You can look at it from different angles and perspectives. But that is the answer. And hopefully you enjoyed this video. Hopefully you learned something new. This is mainly just converting from cylindrical coordinates uh, to the XYZ system. The what's it called? The Cartesian coordinates or rec the rectangular coordinates. Right, so that's really all we did over here. Just make sure you understand. So I think one important thing to note, because there was no z mentioned over here, you just take z such that z belongs to all real numbers, right? So it's all the way up, all the way down. And then you can denote that in different ways. Maybe you can draw like an arrow in either direction, something like that. Maybe you can just draw the circle and then suggest that it extends forever like this. Maybe draw an upper and lower thing, shade it in like that. Enough ways to go about doing it, but it's basically a cylinder in forever in each direction. And then this is, I believe the correct name for this would be, in case you want to look it up a little, it's an elliptic paraboloid. So hopefully this video helped. I know it was a little rambling and the graph might not be the best, but hopefully you still learned something new. Thanks so much for watching.